Okay, hit clear, right? And now let's do the sine of 2 pi. And we'll find out whether you're in radians. Should be 0, right? You're already done with your full cycle. Full cycle is 2 pi, right? Why is this radians and not degrees?
Because it has to do with the distance.
Right. This is a pure number. This thing here is a pure number, omega times t. Omega is radians per second, yes? And we multiply by seconds, so what we feed into it is just this pure number in radians, right? We could contrive to make it work for degrees, but let's not, okay? So when we're doing stuff, angles in degrees and components and stuff like that, use degrees, because I think it's easier to think of 30 degrees and picture that than it is to think of whatever that is in radians. I didn't pay, yeah, what is it? Yeah, okay. So there we are, okay? Our calculators are in radians, and we can go back here. So a simple harmonic oscillator, a show, okay, goes up and down and has a period of 12 seconds and an amplitude of 5 meters. If it starts in the middle going upward, well, starting in the middle and going upward means we can use this for our position formula, because that's what sine does. God help us if they say it starts at a position of 1 meter going, I don't know how to, we could figure it out. I don't really want to, okay? What I would have to do is I'd have to say like time minus something, or I don't know. Okay. Apparently IB doesn't get into that, so let's go with this. It starts in the middle going upward. This is going to be, we're going to use this one or this one, right, for our formulas. And the first thing says, what is its position in 6.5 seconds? So let's do what we need to do before we calculate that, right? Okay. So step, I need like a remote control little motor on this camera. Yeah, just like a little joystick. All it needs is like a little zzz, zzz. In fact, we could, even just 2 positions, like wide on this, tight on the board, right? Just have like a little preset thing. I don't know, either that or not, right? Okay. I'm going to put our precious little formula down here. V is plus or minus omega square root of. Okay, so the first thing I want to do is they told me that the period is 12 seconds. So t is 12 seconds, right? Okay. The amplitude is 5.0 meters, which means it's going to move a lot more than this thing, right? So holy cow, there it goes, right? Okay, it's going 10 meters, 32.81 feet, up and down it goes, right? Okay, or left and right or something. Well, this is up and down, okay? So what we need to do is we need to figure out omega. So omega is, well, that's going to be 2 pi divided by 12, right? And I'm going to store that in a location. I'm using this formula right here. So that's my first thing. Oh, come on. There we go. So let's go 2 times, I know I don't have to say times, but these calculators are so wacky that I never want to rely on the default behavior. And then I have to go second alpha A. I'm going to store that in A. That's, I could store it in W, but there it is, right? So there's my omega is 0.523598. That's probably enough, right? Radians. Okay. Let's go back to, no, I want to go back to that. There we go, right? So what is its position in 6.5 seconds? What is its velocity in 6.5 seconds, okay? So for part A, right, to find its position, I'm going to use x as x naught times sine omega t, right? So that really, basically, that's just going to be 5.0 meters. That's its amplitude, sine of, and then I can use this number, right? I can go 2 pi over 12 times, and what did it say, 6.5, right? This number for me is A. Now I've stored it in some memory location. Stop the madness. Okay. So don't want a second function. I want to go 5 sine of alpha A times 6.5, right? Yeah? Well, that's crazy. Where is it? So at 6.5 seconds, it's... Does that make sense? Because it's 6 seconds, where is it? Halfway through the complete cycle, what is it? It's right at 0, right? So now we've seen it. It's actually going really fast, and at half a second later, it's actually 1 right? So we're looking at a full cycle of this thing, right? Here it is, right? Yeah, right? Here is 6 seconds, here's 0 seconds, here's 12 seconds, one complete cycle, right? At 6.5 seconds, it's here, it's down, it's below the origin. Isn't that beautiful? Isn't math a beautiful thing, right? I can also go 5 sine, and I can just type the number in, right? I could not be lazy. 2 times pi divided by 12 times 6.5, right? Is that going to work? Yeah, it'll work, right? Notice it multiplies by 6.5. 6.5 is in the numerator, right? There we go. So the answer to that is negative, how many sig figs do we have? 2 sig figs, negative 1.3. Is that going to work if you're in degrees?
No.
No. It gets its units from here. This is a unitless thing, right? Okay. Okay. Okay, what's its velocity in 6.5 seconds? Well, there's 2 things we could do. We could figure out its speed by plugging this position into this formula. But we want to know its velocity. This thing is going to tell us plus or minus something. But for its velocity, we can find it with this guy, right? So I'm going to use v as v naught. But what's its maximum speed? Uh-oh. Well, write this down. It's not in your data packet. Okay? What maximum speed are we going to get out of this formula? What is the maximum we can get? What do we plug in? X naught is 5. What do we plug in for x to get the maximum?
25?
What do we plug in for x? This is x squared. Whoops. What do we plug in for x to get the maximum?
0.
0 is what we plug in. Does it make sense that we are at equilibrium, equilibrium being this point here, to get the maximum velocity? Yes? Right? Does that make sense? So if I plug in 0 for this guy, what is the square root of 5 squared minus 0? It's the square root of 25, which is 5, yes? Okay. So isn't this always going to become at equilibrium, right? V naught is equal to plus or minus, right? Actually, I'm just going to say the maximum, right? It's going to be omega times the square root of x naught squared. Well, what is that? It's just x, isn't it? Okay, so this formula is not in your data packet. I'll just write it up here, right? V naught is omega x naught, right? And that's just beautiful. The cool thing is that nobody really knows how to take the derivative of this. This is killing me. This is killing me. When you take the derivative of this, something called the chain rule, take this thing out, you toss it in the front, right? So the derivative of this is sine, and if there's a function in there, you take the derivative of that, stab it out in the front, and you've got it. So it's just omega x naught cos. Okay. Anyway, we don't know that, but here it is. So when you learn calculus, this will be much easier. Okay. But this is not in your data packet. Remember that, and there it is, right? So let's solve this problem. V naught is equal to omega, which is this guy here, right? So 2 pi over 12, right, times the square root of 5 squared minus 0, right? So I'm using this formula here to find that, right? Which means that it's really basically it's just omega x naught, right? Okay. And then that equals, there we go, back to the calculator. Okay. Why is it always a second function? Okay, so let's go alpha A times 5. Storage alpha B. There we go. Okay, 2.61799, right? Right, so this is going to equal our maximum velocity, 2.61799, right? Cosine of omega, right, which is this guy here, 2 pi over 12, right, times 6.5. Okay, so now we plug this in. What do? We do this guy, alpha b, okay, times cosine 2 times pi. I guess I could say pi over 6, right? But, divided by 12. So there's our omega, right? Times 6.5. Yeah, do we get that? Anybody else get that? So the velocity is is negative